Hi everyone, it's Mrs. Martello. We're going to look at section 5.4 and we're still looking at solving systems of equations, but we've learned all the methods of solving. What we were going to talk about in this section is the number of possible solutions that we can get. So I wrote down some notes here to go along with this visual diagram, and it might be helpful for you to write this down, so I would pause the video and copy down what I have written here. So the possible number of solutions are one solution, no solution, and infinitely many solutions. Let's look at each case of these. If the system has one solution and we graph that system, that means that the two lines are intersecting and that the solution is that point of intersection. And that's what we did in section 5.1 when we solved by graphing. Okay, if we have one solution and we're solving, like by substitution or elimination, we should be able to find an x and a y. Together, they make one single ordered pair, which again represents that point of intersection. Now, the other two are special solutions. Remember, special solutions happen in some cases, not always, but they do happen sometimes. If you're graphing and the lines end up being parallel, that would mean it has no solution, because remember that the solution is the point of intersection. But if their lines are parallel, then the lines would never ever intersect. So that's why this has no solution. Okay, if you're solving the equation, it would be no solution if all the variables cancel out. So all the x's canceled and the y's canceled. You're only left with constants, but you have a false result. Like, say, example, you have 1 equals 2. Well, that's not true, that's false. So that would be a no solution case, which means that, again, the two lines never intersect. Our third option is infinitely many solutions. So when we have this, remember, a system is actually two equations, but in this graph, you only see one line. There really are two lines. It just happens to be that one is the same exact line as the other. So technically they're on top of each other, which is called a coincident lines, when one is the same exact line as the other line. Okay, if we were talking about solving it by hand, infinitely many solutions, you can also use the abbreviation IMS, is again when all the variables cancel out because it's a special solution, and it's a true result. So we end up with like 2 equals 2, which is true. So that would be infinitely many solutions. And what that means is that any point along the line would be a solution. Because if there are two lines here, one on top of the other, then this point's on both of them, this point's on both of them, this point's on both of them, this point would be on both of them. So any point along the line would be a solution, and since lines go on forever, that's why there are infinitely many of them. Okay, we're gonna look at some examples like this. Let's take a look at example 1. So in example 1, they're giving us these two equations, y equals 2x plus 1 and y equals 2x minus 5. Now you can choose to solve this however you want. If you want to solve by graphing, you can do that. So go ahead and graph it on a coordinate plane, or you can graph it in like a calculator or in the free online calculator in Desmos. That's up to you. If you plot your y-intercept of 1, and then our slope is 2, we're going up to right 1. Here's our first line. Our second line has a y-intercept of -5, and the slope again is 2. So we go up to right 1, up to right 1, and there's our line. And you should notice these two lines are parallel. So they have parallel lines, which means they're never going to intersect. We know it has no solution. Just to point out, the reason that these lines are parallel is because that they have the same slope. If you go up to over 1 on the first line and up to over 1 on the second line, they're going to end up being parallel. So when they have the same slope, that's parallel lines. The second method that you could use to solve this, if you don't want to choose graphing, you could use substitution. So because they're both equal to y, you can take this first equation for y and substitute it into the second y, like how we did in section 5.2. So if I take 2x plus 1 and plug it in, we're going to get 2x minus 5 equals 2x plus 1. And then when we solve this equation, we would subtract 2x from both sides. And look at that, both of the x's cancel out. You're left with -5 equals 1. This is false. -5 does not equal 1. So this has, again, no solution. Okay, let's take a look at another example. We're going to look at example 2. In example 2, it says, solve the system of linear equations. We have -2x plus y equals 3 and -4x plus 2y equals 6. You could solve by graphing. If you were to graph both of these equations, what I would probably do is I would make them both y equals mx plus b. Solve for y, solve for y. What would happen is you would notice that you end up getting the same equation. So when you go to graph it, it's the same exact line. So since both lines are the same line, that means that it has infinitely many solutions. I probably would not choose graphing for this, since you have to solve for y and then graph them. Seems like a lot more work than just using elimination. So elimination would be the way that I would solve this. Okay, looking to solve by elimination. If I want to get one of these variables to cancel out, it doesn't matter which one you choose. You can choose either the x's or the y's. Let's say we chose to do the y's. If this is already a 2y, let's make this one into a -2y and get them to cancel out. So then we're going to multiply this first equation by -2. This would become +4x minus 2y equals -6. And the second equation would stay the same. Now, the y's have the same coefficient, and we're going to add these two equations together, but look at what happens. The x's cancel out, the y's cancel out, leaving us 0 on the left. The constants even cancel out, leaving us with 0 on the right. Well, since 0 does equal 0, this is true. That means that this has infinitely many solutions. Okay, so special solutions are going to happen when all those variables cancel out, and you would just want to think about the result. If it's true, infinitely many solutions, and if it's false, no solution. Let's do 2 examples like this. We're going to look down here at monitoring progress 1 and 2. So for monitoring progress number 1, we have x plus y equals 3 and 2x plus 2y equals 6. Okay, so to solve this system here, I'm going to solve by elimination. And the reason I'm choosing elimination is because the equations are in the same form, right? This is the x's lined up, the y's are lined up, the constants are lined up. So because they have that same form, I'm going to choose elimination. So to solve by elimination, let's pick a variable to cancel. Well, they don't have the same coefficients right now, so I'm going to have to multiply. Let's choose to do the x's. If this is a 2x, let's make this one a -2x. So let's multiply this first equation by -2, and then we can get these x's to cancel. Let's write our new equations. This would be -2x minus 2y equals -6. And our second equation stays the same. 2x plus 2y equals 6. Now we're ready to solve. I'm going to add these 2 equations together. -2x and 2x, they're eliminated. Now look at these y's, -2y and 2y. They also get eliminated, leaving us nothing or 0 on the left side. Let's add on the right side. -6 and 6 is 0. All the variables canceled out. This is a special solution. Because this is true, that means that there are infinitely many solutions. Or we can write IMS. Okay, let's take a look at one more. We're going to do monitoring progress number 2. Y equals -x plus 3 and 2x plus 2y equals 4. Okay, let's decide how we're going to solve this. So I think I'm going to choose substitution to solve this one. These equations are not in the same form, so it would not be easy for me to choose elimination. Substitution is definitely the best way to go for this one because this first equation is equal to a variable. That's what I want when I use substitution. So because this equation is equal to a variable, I can take that expression of what y is equal to, and I'm gonna plug it into this equation for this y. So let's substitute it in. We're gonna keep the 2x plus 2 times the quantity of what y equals, negative x plus 3, and then equals 4. Let's solve this equation. We're gonna distribute over here. We get 2x minus 2x plus 6 equals 4. Let's combine our like terms. 2x minus 2x, they cancel each other out, and we're left with 6 equals 4. Now all the variables are gone. This is a special solution. Let's look at this result. Well, 6 does not equal 4. This is false, so this is no solution. Or you can use this symbol for no solution as well. And these are our special solutions. It doesn't always happen they're special solutions. It might end up working out. You might be able to find an x and a y, which again is one solution, but it is possible to get these special solutions too.